Okay. So I'm going to be talking about how I've used ACPF and how our department is using it for our watershed planning and implementation efforts in the Lower Fox River Basin here. So just a little overview. In 2012, total maximum daily load for phosphorus and sediment was approved for the Lower Fox River Basin. So as a result, Outagamie County Land Conservation, in collaboration with the adjacent counties, started developing 9 key element watershed plans in 2014. So a watershed plan that meets EPA's 9 key elements is required to be applicable for Section 319 funds. So that's kind of the reason we wanted to get those plans, was to get the funding. So the Wisconsin DNR had developed the erosion vulnerability analysis for agricultural lands tool, which is the eval tool that you've heard mentioned. So we started using that when we started plan development in 2014. So after attending an ACPF training in 2016, I also started running the ACPF tool in addition to the eval tool for the watershed planning process. So this map here is just kind of showing the 9 key element plan development and implementation status so far in the Lower Fox. So all those watersheds in green there are ones that have approved plans, and we have some sort of form of grant funding to do implementation. So we have been doing implementation in those areas. The yellow watersheds, we're kind of waiting for funding to begin implementation. And then all those watersheds in orange are kind of in the different stages of development, or a draft has been complete. And the ones in purple are kind of where we're looking to move next. So a little background on the characteristics of the Lower Fox Basin. This is on the left is a land use map. So all that yellow area is all the agricultural land use. The red areas are urban. So the Lower Fox is pretty heavy dairy rotation on the ag land. There are some areas of cash grain. The topography here is mostly flat with some gently sloping hills in some areas. So many of the tributaries to the Lower Fox River are actually very entrenched along much of the main stem of the corridor, and then have high occurrence of stream bank erosion. I also wanted to point out the tile drainage is also fairly prevalent in the Lower Fox Basin in some of these sub-watersheds. And those tile drain fields are shown in those blue squares on the map on the right there. So the specific tools that you're going to find useful to you from a watershed planning perspective will be based on the characteristics of your watershed and the pollutant you are trying to reduce. For example, I usually don't run the edge of field bioreactor tool because bioreactors are mainly for nitrate reduction, and we are looking to get phosphorus and sediment reduction in the Lower Fox. I also found the contour buffer strip tool is not particularly useful either for most of the sub-watersheds in this area due to the mostly flat topography. So I'm going to just kind of highlight the ACPF outputs that we use the most for planning and implementation. So the output that is used the most for implementation, or for planning and implementation purposes, is the stream power index and the resulting grass waterway vector. So I use the stream power index and the grass waterway vector to identify gully erosion and concentrated flow areas in a watershed in conjunction with windshield surveys, field inventory, and air photo interpretation. So eval also has a stream power index output, but the ability of ACPF to vectorize the index based on a specific stream power index value makes it much easier to work with. So as I mentioned, as part of the watershed planning process, I use this output along with aerial imagery. So we get 6-inch aerial imagery photos taken every few years. So you can easily zoom in on those areas identified by the stream power index, and usually you can tell that there's actual gully erosion there, and just verify that with the air photo. So at Outagamie County, we have also been using Esri's Art Collector app for field inventory and verification. So originally we started out with putting that stream power index in there, but the vector grass waterway output makes it much easier to add that layer into an Art Collector app for use in the field. So this layer is helpful for agronomists and technicians when walking the field to identify resource concerns. So in the screenshots shown here, the yellowish-orangish lines are the stream power index, and that icon highlighted in blue there is where a gully was confirmed by a technician as occurring during a field walk. So other outputs of ACPF, such as WASCOBs, depressions, and saturated buffers, could also easily be added to an art collector app like this to use for field verification purposes. So this is just another example where gullies were actually identified during the stream corridor inventory, and those are those red and yellow dots you see there. And the pink lines are that actual vector grass waterway output from ACPF, so you can see how well that actually corresponds to what was found out in the field. So moving from the stream power index onto the WASCOB tool. So for watersheds in the Lower Fox, I will usually run the WASCOB tool twice with the embankment height of 1 meter and 1.2 meter based on that adaptation guidance for the tool, since most of the fields in the Lower Fox Basin fall into those first two categories of less than 5% slope. And then what I usually do with those outputs is I'll actually create a copy of each layer and edit those copies of the layer. So in the Lower Fox, there is ravine and gully erosion in the forested riparian corridor. That is a major resource concern in some watersheds, where the grade stabilization embankment height recommendation of 4.5 meters would apply. But the tool, but this is not picked up by the tool because the tool is limited to those ag fields. So that is a limitation that where it might be useful if we could get it to run in those riparian corridor areas, if it could pick those up. So one of the requirements of the 9-key plan is to estimate the sources of pollution. So in our case, sediment and phosphorus, quantify pollutant loads, and then estimate quantities of BMPs needed. So several of the ACPF practice outputs can be used to do this. So I will create my own gully and concentrated flow layers for a watershed using the ACPF grass waterway output, air photo interpretation, and any field inventory data that I have. So from this layer, I can get an estimate of, total linear feet of gullies and concentrated flows in the watershed needing stabilization. And then I can also estimate an average width and depth. So these attributes can then be plugged into STEPL to estimate loads, which you can see up here where you have the top width, bottom width, length there, and then it'll show you the load on the end. So this map shows the gully and concentrated flow areas that were determined using this process, and this is in the Outagamie and Dutchman Creek watershed. So kind of highlighting the areas that will likely need to be stabilized with, a grass waterway, critical area planting, and then also the WASCOB output tool. The edited WASCOB outputs are on that map as well. And this is just a table from one of the 9-key plans, highlighting how you can estimate those quantities from some of these outputs and plug that in and get an estimated cost. So once the 9-key plan is approved by EPA and DNR for a watershed, we usually try to apply for grant funds to start implementation. So the ACPF and eval tool data used in a 9-key element plan helps us guide our grant applications and the types and amount of practices needed in an area and how much funds are needed. So we use eval and ACPF data to create landowner maps, identifying priority areas for agronomists and technicians to use with landowners. So the landowner map shown here shows those high stream power index values in red, and then some of the suggested grass waterway locations in yellow. So farmers so far in the Lower Fox have been pretty receptive to these maps and have confirmed that they do have erosion issues on many of the areas identified. Here are just some before and after photos of some of the gullies identified in the previous map and some of the practices that we had implemented. So we ended up implementing practices on several fields with this landowner, and it had some waterways, diversions, and WASCOBs in multiple locations. So many of the concentrated flow areas identified by the high stream power index do not have severe enough gully erosion that a design grass waterway or a wascab would be required, but would still benefit from being vegetated. So we have learned that most farmers try to leave these concentrated flow areas vegetated, but often there's a miscommunication with other farm workers, sprayers or manure haulers on avoiding these areas. So we have been using the stream power index data to create GIS shape files that we can provide to the sprayers and manure haulers and field equipment operators so that they can easily avoid these sensitive areas. And here is just an example of that map sensitive area that we provided to a landowner. Here is just a before and after of a concentrated flow area that was mapped, and then what it looks like now that they have that GIS information to avoid those areas. So we've also been using the runoff risk output shown here of ACPF with eval erosion score data and soil test phosphorus that we have mapped from nutrient management plans to prioritize our targeting of field management practices. So this project here was one example of how we did that. So in 2016, Alliance for the Great Lakes received grant funding to work with producers and project partners over 3 years to highlight how perennial forages are a win-win for agriculture and water quality. The goal was to implement 2,000 acres of perennial forages and high priority fields in 3 sub-watersheds in the Lower Fox River Basin. So using the ACPF runoff risk, eval erosion score, and then average soil test phosphorus data, I was able to put together an ArcGIS online web map that the project partners could use to prioritize fields. So in the map here, this kind of middle watershed is the Apple Creek watershed. So I just have all 3 layers turned on, and you can kind of see it's kind of messy. Schwabenon Creek is here, and this is just the eval erosion score turned on. And then on the bottom here is the Upper East, and that just has the ACPF runoff risk turned on. So by creating a web map, it makes it easy for the user, in this case, the crop consultants and agronomists, to turn these layers on and off to prioritize fields. And then by including the soil test phosphorus data on top of the eval and erosion score data, we can then further prioritize the fields. So for example, a field that is high runoff risk but may have low soil phosphorus would then rank lower than a high runoff risk field with high soil phosphorus. Another example where ACPF, eval, and soil test phosphorus data was used in combination was for prioritizing field walks for New Water's Adaptive Management Program. So New Water is Green Bay's Metropolitan Sewerage District in Green Bay. So they had chosen the Schwabenon and Dutchman sub-watersheds in the Lower Fox River Adaptive Management option for the permit compliance. So Jacobs Engineering, their consultant on the project, developed a scoring system for fields in the watershed based on soil test phosphorus data, ACPF and eval outputs, and potentially restorable wetlands layer. And that was used to rank fields for priority of field walks for implementation. The table on the left shows the scoring criteria for each data set used in priority ranking for the field walks. And on the right is the resulting field walk prioritization showing higher priority fields in red and then the lower priority fields in orange. So this layer was added to ArcGIS Online to be used in the field and in our collector app. So technicians and agronomists would know which fields to target first. So I'm going to talk a little bit about tile drainage water management tool of the ACPF. So at Outagamie County, we map tile drainage in the Lower Fox Basin using air photo interpretation. So when running the ACPF tile drainage tool, I will usually update that output with what we actually have mapped. So for our area, the tool seems to overestimate tile drainage when using the more inclusive parameters, and then it underestimates when using the more restrictive parameters. So this is the Bower Creek watershed, and the yellow hatching on the map shows what we have identified as having tile drainage, and then the orange is what was predicted by ACPF using kind of the more inclusive parameters. So you can kind of see there's some differences there. So just from experience, I would strongly suggest editing this output when you're running the tool using air photo interpretation if you already don't have some of this data mapped. So this is just two maps that I've used in a 9-key element plan. So on the left is that edited tile drainage output. And then on the right is going that one step further and running the drainage water management tool. And I use the economic suitability for that to try to cite areas where tile drainage water management would work in the watershed. So didn't really show a lot of places. This isn't something we have implemented in the Lower Fox yet, but we would be looking to do to kind of try to find a way to treat that dissolved phosphorus from tile drainage, as there is some significant tile drainage in some of these sub-watersheds. So as I mentioned before, several of the ACPF outputs can be used to estimate load reductions using the STEPL model. So this is the BMPs tab of the STEPL model, if you're familiar with it. So kind of already preloaded BMPs and their efficiencies. So as you can see, controlled drainage is actually included in there. So that's one where you could take that acres of that controlled drainage output and easily plug that into the STEPL model and see if you implemented that whole area, what your reduction be, or maybe you only implemented 50% of that. So that's kind of how you can start playing around with those different scenarios and estimating reductions using the ACPF data. Here I have the riparian analysis polygons, and that is symbolized by the runoff rank, and then the riparian catchments shown with those black lines there. So to calculate estimated reductions for buffers, you would need to know the catchment area treated by the proposed buffer. So this is where the riparian catchment layer comes in. So you can select an applicable, select applicable riparian catchments for the proposed buffers and export just the desired ones. So you will want to review the riparian catchments chosen for accuracy and to look for ones that may include large drainages that are actually going to channelize flow. So such as this catchment highlighted in blue here. You can see that a lot of this drainage is actually just going to this channel here and is probably not really going to be treated if you were to put a buffer here. Just because the riparian analysis polygon is rank type for runoff does not necessarily mean it would have the capability to treat all the runoff in the catchment if it is channelized flow. So if you are going to use this to estimate reductions in STEPL, you'll want to edit the selected riparian catchments as necessary and recalculate the area before estimating load reductions in STEPL. And just on the bottom here, kind of showing the example buffer input and an example reduction. So Outagamie County was also part of a technical group for the Lower Fox Green Bay area of concern eutrophication beneficial use impairment. So this group was tasked with estimating the quantity needed, cost and expected reductions for 5 practices throughout the Lower Fox River Basin. So the practices included wetland restoration, treatment wetlands, stream bank restoration, and 2-stage ditches. So this is kind of one of the maps that was developed for the project, showing all those practices. For the saturated buffers, that was just regularly using the ACPF to get that output. But for the 2-stage ditches, we had to kind of figure that out indirectly using ACPF. So 2-stage ditch siting is not a tool output in ACPF, but we used the flow network area threshold tool to generate different acreage drainage lines to identify stream lengths suitable for 2-stage ditches. So the NRCS open channel standard states that the 2-stage channel design is applicable in drainages greater than 640 acres that do not exceed 6,400 acres. And then based on local watershed knowledge, Outagamie County determined that drainages between about 80 and 640 acres would probably also be suitable for this practice, but just wouldn't be eligible for the NRCS funding. So therefore, we created 3 flow networks using the 80 acre, 640 acre, and 6,400 acre threshold. And outside of that output, we then calculated the stream gradient for the 80 acre flow network segments, since 2-stage ditches are best suited for low gradient drainages less than 1%. So then the stream segments meeting the criteria for the drainage area and gradient for this practice were then identified from the resulting drainage lines. So that's kind of just a high-level summary of the different ways we have been using the tool and some of the different projects that the data was used on. And I'll open for questions.
Thank you, Sarah. There are a few questions. There are a couple, if you want to expand anything on the use of SNAP Plus. I'm really glad you talked about eval, STEPL, SNAP Plus, and how these can connect. Fred, before the break, asked, will this be able to utilize or consider tillage practices and T-loss of ag fields within watersheds from SNAP Plus data?
I'm not quite sure what he's asking there. Is he talking about using the SNAP Plus data and plugging that into the model?
Fred, if you want to, you're welcome to clarify what you're thinking.
Can you hear me?
Yes.
Yeah, I was just want, because we were talking about like in the soil erosion risk assessment, runoff risk assessments. I guess I was wondering, you can have soil types that are high risk runoff, but if they're say they're in cover crops, not being tilled, it's taken away on that erosion issue. But then you might have soil that's not so susceptible, but the guy's moldboard plowing or chisel plowing and disking, and it's just creating, it's a higher risk than a high risk soil that has a cover crop on it. And I was just wondering if there's a way to implement that data into this program. If it's going to take that in consideration and tillage practices in those ag fields towards the runoff risk assessment.
Currently, I don't think it really does in the ACPF. I know in the eval, when it's doing the erosion score evaluation, it's looking at that land use data and calculating, that C factor and curve number. But I don't know how well that's really going to pick up, your tillage types. I know there had been talk a while back of trying to, incorporate that. And there was, I think, Teresa Nelson a while back when she was working with the DNR was looking into using, I don't know if you're familiar with the normalized difference tillage index. So that's kind of a rough way to estimate tillage practices using satellite imagery. But I don't ever know what that. But yeah, as of right now, you're right. That's really not kind of taken into consideration in these models.
Okay, thank you.
See, Mitch McCarthy just asked a question. Someday, will CPF, eval, and STEP all be combined into one modeling tool? Yeah, wouldn't that be sweet?
That would be great.
And there's been some thinking on that, but this is a real good question to talk about on Tuesday when we talk about all of Wisconsin resources and looking forward and what's needed and what's possible. So I would suggest that we continue that conversation then and figure out what would be desirable and maybe how Wisconsin could move that direction. let's see, Sarah, I had a question. Have farmers been put off at all by the level of detail in the maps that you share with them?
I would have to defer that to Jeremy. He's more of the one that works closely with them on that end of actually. I don't know if he's still on here.
Oh yeah, I can chime in. So surprisingly not turned off. I guess we started with eval 5 years ago before ACPF was a thing here, and we identified the eval also has a stream power index as part of the routine, but it ends as a raster, which is hard to do for, like Sarah talked about, for going to find them in the field. That doesn't work because the raster doesn't well with publishing online data. But we made these map books for each farm and showed them the eval score with the stream power index. And I was concerned about getting it out on the table and throwing it out there, and it became a confession session, if you will, of yeah, I know that happens every year, and it started to lead towards some acknowledgement. And I think why that is not every field and every part of every field gets lit up as being a concern. So that's what we wanted to come across to the farms is, if you have to prioritize conservation, please do it where the models say it's red or orange or yellow, and where it's green, if you only have enough resources to deal with 40 acres on your farm in this different way of farming with cover crops and no-till, please use these maps. And then so we didn't get much pushback. Not to say that's not the case for anywhere in the world, but it was actually they were impressed that we could identify that, and it hasn't been negative since that I know of.
I like your point that also highlights the areas that are not a problem. That's a good way to think about it.
Well, I would just add, because the last thing you want to do is show up and say your whole farm is bad and stop farming, right? That's not what we're here for. It gives them that that barometer too, of where to focus. So there was some talk to like, where do you go next, for that previous question that Fred had for Sarah. And I think we're starting to answer some of those questions with a new GLRI grant we just got for the Lower Fox to look at like a progress report for SNAP Plus, in which we can identify how far a farm needs to go, or identify those wins when they're doing cover crops on those bad fields. So stay tuned on that. I guess hopefully we'll have that done in 3 years.
The next question coming from Corrine: have you done any surveying to see how many people are using the tools you have, meaning the website where you have posted the maps and outputs for people to use as they work in farming?
So for that first map I talked about, for that project, that was mainly used for the agronomists and consultants that they had on the project. So they were using that, and I know they were using it to kind of print off maps too when they were working with the landowners. But as far as like sharing those that data publicly on the website or like on an ArcGIS online web map, we really haven't done that too much. I wouldn't know. I've only created like one map for one of the watersheds that has some of that data that's open to the public, but.
So I would just add then that rarely do we get feedback back once you get a tool out there like that. So we know that the crop consultants are using that to advise their farmers, but there's no expectation that it'd be, in a perfect world, they'd come back and say, hey, I convinced Farmer Joe to do X, Y, Z because of those maps, but it's pretty private stuff. And so the NDTI is where we're starting to get at, where those changes are happening without our contracts or cost sharing or influence, because we don't get reported on when they made a change on a farm. Ideally, they would let us know, but it's encouraging that the private agronomists are using that data to try to persuade their growers to do things differently.
Carolyn asked, how many types of BMPs are included with ACPF? If you go to the user manual and look, it has a list of the practices. There's about 9 of them. in there. So a lot of the tools in the ACPF have to do with hydromodifying the DEM and setting up the stream network. And I hope after listening to Kent and Sarah, you have a sense of why, if you remember on Tuesday, I said it can take a couple of days for a single watershed to determine that stream network and go through all of that. It can take longer than a couple of days. But then once you have that, actually running the tools for locating the practices, that goes fairly quick. Dane Christensen asked, how did you get all the field soil test P averages?
So we, well, starting back in 2014, we had started mapping just from the nutrient management plans, creating a GIS layer and type mapping those every year. But recently, we've been working with the SNAP Plus folks, and we're kind of doing like a pilot project of getting them to actually share those SNAP Plus field boundaries just with certain attributes on them, like the soil loss T and soil test phosphorus. So we're trying to convince them that this is something that should be kind of done statewide, because a lot of counties would find this information helpful, because most counties don't have the resources to have someone sit there and map out nutrient management plans every year.
Good. Any other questions for Sarah and Jeremy? Jeremy, did you ever introduce yourself? You could tell people who you are.
Oh, thank you. I did not. So Jeremy Freund, environmental engineer and project coordinator for the Outagamie County Land Conservation Department. And so my main project is Lower Fox implementation and working on the large scale trim grants and GLRI funding that we secure.